Thanks for having me here today. So today I'm going to present Safe Junction, which is a new project we have been working on at the Cross-Chain Interoperability Alliance. So we started working on proofs. So we think proofs basically will soon be everywhere, and they are of critical importance for a bunch of scalability solutions in the blockchain space. So DePINs, in general, make heavy use of proofs, but proofs are really like something we cannot circumvent in any way. Let's look at what proofs are used for before diving into what kind of problems the proving ecosystem has and how we can solve it. So proofs are sort of the enabler of like vertical scalability. Like layer 2s are secure if you can challenge them. And challenges of layer 2s are possible via some kind of proofs, which you must be able to enforce on the underlying layer, on the layer 1. Horizontal composability, meaning shared sequencing, is similarly in strong need of proofs. Oracles, clearly, like if you have, for example, data coming from web APIs, you need to enforce data authenticity. You normally do this via proofs. And co-processors, which is like a trend we have been like hearing a lot also in previous conversations, in previous talks on T co-processors and ZK VMs, stuff like that. They all need proofs in order to be secure. What are the problems there? So actually many more than what we normally realize. So there is a lot of fragmentation and inefficiency. Today, when we want to interact with like the proving universe, with the proving ecosystem, there are many things that unfortunately are given for granted. Like for example, one of these is that like you design your system based on top of another, and what's really happening is that you are being locked in. So if there is a vulnerability in their code base, in their like trust assumptions or stuff like that, it creates a systemic risk also for your application. Other problems are around like verification costs, for example. It may be extremely gas expensive to verify a proof on chain, or about like also the possibility to verify the full chain of trust on chain. Similarly, there are complexity with today. I think we don't really have the tools to analyze and understand in full regarding the trust assumptions. So in conclusion, the proving universe is improving, is getting better. It's providing a lot of primitives we need for scalability and security, but it's not quite there yet, and it's in strong need of like solutions to fix like these weak spots. What you can see here is like a map we have done of the proving universe, and on the top left, for instance, you can see co-processors like ZK VMs, such as SP1, RISC0, Jolt, and so on. You can see some T VMs, so virtual machines that enable generalized off-chain computing with trust execution environments backing it, such as the Accurast one, for instance, or the Proofcast one, or many others that you may know. And promising like research at this stage of FHE VMs as well. Other components that are important primitives are the aggregators. You may have heard the names of Aligned Layer or Nebra, Electron Labs with their Superproof. All these are critical components that can make the proof verification on chain more feasible, like cheaper and actually viable. Also the infrastructure, like we are here for DePIN. Many networks for DePIN actually have a lot to do with the generation of proofs in a decentralized form. Like Accurast, for example, is both a co-processor and a proving network. So you can offload the execution of the proof to their network of provers, and somehow a device will be selected, will generate the proof, and return the proof for your consumption. What Safe Junction does is basically taking care of all this complexity and covering what's missing. So it's giving an abstraction layer so that the interaction with all these complex components is actually made simple. This is of critical importance because today the shared feeling we are hearing is that a bunch of projects would like to make extensive use of, but they are not doing it. Because in some cases, they don't really know where to start from or what to choose among what's available, like different coprocessors, the different aggregators, and so on. But also just because it's just too complex and fragmented, and they're afraid of security and of lock-ins. So what you can do is introducing like a new layer of abstraction that helps both avoiding lock-ins and providing additional security. So this is what we are trying to achieve with Safe Junction, and let's see how we actually can achieve it. This is by adding to the picture 2 new ingredients. So one ingredient is called T-Rust, and it is an SDK where you can write code that looks like normal Rust code that you would execute locally on your machine. But in reality, thanks to the abstraction of T-Rust, can be compiled and executed on different proving backends. We call them backends. In reality, what they are different coprocessors. So you can just write one line of code which says things like compile for Accurast, compile for SP1, compile for Jolt, for Proofcast, whatever, and it just gets compiled without changing even one line of code. So this enables writing your code once, auditing your code once, and then executing it wherever you want. If tomorrow there will be like a new breakthrough or some kind of innovation in coprocessors, you will be able to like plug it in as a proving backend into T-Rust and reuse the existing code you have. Also, the execution is very important and critical, because what you enable by having this abstraction, this T-Rust SDK, is basically redundancy. You can pick up a piece of code and you can execute it on several proving backends redundantly. So this may look like inefficient, but in reality what it gives you is the best of both worlds. You can have T's giving you a quick result, which is like backed by an attestation, and that comes very quickly and maybe efficiently, and that you can verify on chain at very low cost. And then maybe waiting some extra minutes, a little bit longer, you can have the results from ZK VMs. So in this way, you don't really have to choose, and you can get proofs from both systems. This is something that commonly is called security in depth. So having different, more than one layer of security, so that if there is a vulnerability in a given system, the other layers are still there to protect you. Another component, which is actually the key part for the simplification and the lowering the entry barrier, is the engine itself, the Safe Junction engine. So the Safe Junction engine is something that looks like a traditional database. So it gives you the developer experience of interacting with a monolithic traditional database, which of course for us as blockchain engineers is something scary, trusted, and dangerous, right? But we write it in T-Rust. We execute it redundantly on coprocessors so that we can actually be sure that in practice, the database is trustless. So this is an important innovation because basically it gives you like the look and feel of something you're already familiar with, but it leverages the complex and fragmented ecosystem of provers, giving you a lot of security. Currently, we have an integration with the names you can see here. So you can basically read the state from this database and trigger on-chain operations based on provable facts that are included by aggregators like Electron Lab Superproof or Aligned. You can execute it on different TVMs or ZK VMs, such as SP1, Powder, RISC-0, Accurast, and the Proofcast TVM. And this is like something that already works today and that you can execute like on, for example, Ethereum mainnet or on any other chain, right? So for example, let's pick Accurast. So with Accurast, for instance, you can choose if you want to write like a bundle for their own platform, right, for their own TVM and execute it natively. So if you have done your own assessment and decided that Accurast works best for you today and it will always do, you can just write it natively there and you're fine. If you prefer to write in Rust, for instance, or want to keep options open and maybe use at the same time Accurast for speed and other maybe TVMs or maybe a ZK VM, You can do it today just by using trust. You write it in trust, and you execute it. You select as configuration the execution on Accurast and SP1, for instance. There are many use cases that depend on this. We have actually worked on some of those that are like going in production in the coming months. Hashi is one of these. It's like an abstraction layer for bridges. It uses many independent bridges like Wormhole, CCIP, ZK-led clients, and so on to secure like different cross-chain messaging, basically cross-chain messaging. And by using Safe Junction, it will be possible to have the redundant security and abstraction of the Hashi bridging solution, along with the lowest possible costs and the highest security. Thanks for your attention, and yeah, if you're interested, feel free to reach out to me.